Hello everyone, welcome to our puzzle video. My name is Amol More and this is our channel Solution to Black Book. Now today the puzzle is let ABCD be a square with side of length 10. So let us first draw a square. So you can see this is your square, okay, and the side length is 10. Let this be ABCD, okay. Now M is the midpoint of BC, so this is the midpoint of BC, which is M, okay. Then P is in the interior of the square such that PM is equal to 5. So let us say P is somewhere here, okay, and they are saying PM is 5 and AP is 10, and this particular part AP is 10, and they are asking us to find out the square of DP. Okay, that's what we are needed to do. So this is the basic ideology of this diagram. So let us move towards the nicely made diagram which will help us. Okay, now let us see this. In this diagram we have many things already marked. For example, this right angle triangle, okay, that we have marked, okay. And now we need to understand how to move towards DP. That seems a very challenging task at first, but there is one thing for sure, that I can see this 10, this 10, this 5 and this 5. Okay, that reminds me of something. Why not prove triangles equal? But for doing that I will need some things. So let me rub this 10 and 5 and let me write that 10 and 5 over here. Let me do an interesting task over here. What I'll do is I'll join AM. See, I have joined AM. Very good. Now if you see triangle APM and triangle ABM. Now I am not going to write down smaller steps. Just listen to my words very carefully. In triangle APM and in triangle ABM, you can see AB side is congruent to AP side, 10 10 each. MP side is congruent to MB side, 5 5 each, and AM is the common side. That means these two triangles are actually congruent. Very good. If these two triangles are congruent, then I can say if this is 90, then this also needs to be 90. Very good. And this angle and this particular angle, these both angles are equal. Okay. So these two angles can be utilized to our advantage. Now, let us try to understand what is that angle. Okay, so let us call this angle as theta. Very good. And let us try to calculate AM. So by Pythagoras I will calculate AM. I will show that because some of you might not understand this at first go. That is why we are calculating this. So AM square comes out to be 125. So AM can be under root of 125. So AM will be 5 root 5, because 125 can be written as 25 into 5 and the square root of 25 will be 5. Very good. So this AM is 5 root 5. Okay. Now one more thing that we need to understand is, can I get theta? Yes, I can get theta if I try to calculate sine theta. Sine theta is opposite upon hypotenuse, BM upon AM. Okay, so BM is what? BM is 5 and AM is 5 root 5. So 5 5 will get cancelled and I will get sine theta as 1 upon root 5. Okay, so therefore I can say theta is nothing but sine inverse 1 upon root 5. Very very important value we have determined. Theta is sine inverse 1 upon root 5. Okay, now there is one more thing, that this angle is also theta. So basically we have known these two angles. Now one more thing which is very important is, suppose this line segment AP is 10 and this AD is also 10. Because that we already know, right? Because AP is given as 10 and AD is given as the side of the square, which is 10. Okay, so basically ADP is the isosceles triangle. So what I will do is I will drop a perpendicular, I will drop a perpendicular I will drop a perpendicular from A on DP. Let us say this is the perpendicular. Let me call this as E. So this AE is perpendicular to what? Is perpendicular to DP. Now consider triangle AED and AEP. The hypotenuse 10 is equal. There is a common side and there is 90 degree. So it is very much of a common sense that these two triangles are congruent. Okay, and there is one more thing. If you drop a perpendicular from an isosceles triangle from the vertex to the base, if you drop a perpendicular from the vertex of an isosceles triangle to the base, then the perpendicular actually does what? It actually divides or bisects the base. Okay, therefore DP will be bisected at E. Those who don't know this property, they can simply prove the triangles congruent, then DE will be equal to EP, just like we proved, okay, by hypotenuse side theorem. Or else they can directly use the property told by me. When the perpendicular is dropped from the vertex to the base of an isosceles triangle, it bisects the base. Very good. Now we also know one very important thing is that if these two triangles are congruent, then these two angles are also congruent. So let me call these two angles as phi phi each. What did I do? I called these two angles as phi phi each. So angle A is comprised of theta plus phi plus phi. That means 2 theta plus 2 phi. Okay. So let us write down angle A is actually equal to 2 theta plus 2 phi. I am interested in phi actually. But angle A is nothing but 90 degree, which is pi by 2. So pi by 2 is equal to 2 theta plus 2 phi. Let us divide both sides by 2. So this will be pi by 4 plus theta plus phi. So phi will be equal to pi by 4 minus theta. But to our surprise, we have already calculated theta as sine inverse 1 by root phi. So this will be pi by 4 minus sine inverse of 1 by root phi. Okay, we got the value of phi also. This is very great. We even got the value of phi. Nice. So first of all, we got the value of theta. Then from theta, we tried to derive the value of phi. Now we have determined the value of phi. Okay. Now we know this particular value of phi, how to use it to our advantage. Now if you consider triangle AED, can I get sine of phi? Yes, definitely I can get that. Sine of phi will be opposite upon hypotenuse, and opposite is D and hypotenuse is 10. Okay, so I can say sine of phi, let us take black pen now. Sine of phi is equal to opposite is DE upon hypotenuse is 10. Okay, let us go and check. I don't want to commit a mistake. Opposite is DE and hypotenuse is 10. Okay. So DE will be naturally 10 times sine phi. Now all the task that is remained with us is calculating sine phi, and that is a little bit tricky. Okay, but we will do that. So sine of phi is actually equal to sine of pi by 4 minus sine inverse of 1 by root phi. I have just substituted the value of phi. Now you can see this is sine of A minus B. So I can say sine A cos B, right, minus cos A sine B. As you can see, instead of A I had pi by 4 and instead of B I had 1 by root phi. That is pretty much interesting. Now sine of pi by 4 is actually 1 by root 2. So this will be 1 by root 2 cos of sine inverse 1 by root 5, and even cos pi by 4 is 1 by root 2, and sine of sine inverse 1 by root 5, as every one of us know, sine and sine inverse nullify each other. So it will be 1 by root 5. Now the only fact which is remaining is cos of sine inverse 1 by root 5. So we will have to calculate that. Okay, so let us move to next page and let us try to calculate cos of sine inverse 1 by root 5. This is very easy. I'll tell you a simple method to do that. Okay, so let sine inverse 1 by root 5 is equal to x. So this will term as cos x. Very simple. Now sine inverse of 1 by root 5 is x, terms as sin x is equal to 1 by root 5. Very simple. Now let us draw a triangle and this angle as x. Now sin x is 1 by root 5, opposite is 1 and hypotenuse is root 5. So what is the square of the hypotenuse? Root 5 square is 5 and adjacent side square is 1. So 5 minus 1 is 4, and let us take the square root of 4, which is as 2. Okay, but our concern is actually cos x. So what will be cos x? You can directly get that from the triangle which is adjacent by hypotenuse. Adjacent is 2 and it will be 2 upon root 5. So basically cos of sine inverse 1 by root 5 is 2 upon root 5. So instead of this cos of sine inverse of 1 by root 5, we have to just write down 2 upon root 5. So let me write that down on the same page so that you are able to understand that in a better way. 1 upon root 2, 2 root 5 minus 1 upon root 2, 1 upon root 5. Very well. So this will be 2 upon root 10 minus 1 upon root 10. 2 minus 1 will be 1 upon root 10. Nice. So d is 10 sin phi. So d will be 10 into 1 by root 10. Okay, just try. Let us just write them down. So de is 10 sin phi, and sin phi was, let us check, we don't want to commit a mistake, 1 by root 10. Okay, so it will be 1 by root 10. So that will just be root 10. Okay, but we calculated de and we had already proved that de and ep are same. So dp will be twice of d. So we need to write down dp is equal to twice of d. So dp is equal to twice of de, which will be equal to 2 root 10 units dp. Therefore dp square will be equal to 2 square is 4 and root 10 square is 10, which is equal to 40. Hence the correct answer to this question is actually 40. So you can see that dp square is equal to 40. I hope you understood such an interesting and complex question of trigonometry, quadrilaterals and whatnot you call it. But I enjoyed solving it. I hope you also enjoyed watching the solution. Okay, if you liked this video, please hit the like button, comment on the video and do spread the knowledge, and do not forget to subscribe to our channel. Thank you for watching the video, guys.